So in this video I will be doing problem 64. 64 says, an object is undergoing simple harmonic motion with period 0.3 seconds and amplitude 6 centimeters. At t equals 0, the object is instantaneously at rest at x equals x equals 6 centimeters. Calculate the time it takes the object to go from x equals 6 centimeters to x equals negative 1.5 centimeters. So again, we start with the period equation. T equals 2 pi over omega, because we want to know what omega is. And we know the period is 0.3, so we plug that in to t. So we'll have 0.3 equals 2 pi over omega. We multiply by omega on both sides, so we'll have 0.3 omega equals 2 pi. And then we want to divide by 0.3, so we'll get omega equals we'll get omega equals 20.94. So then we get our position equation, which is x equals a cosine omega t plus theta. And it told us it's at rest at this time, so we know the phase angle is 0 because the velocity isn't moving, since it's not moving at all. So we just have x equals amplitude times cosine omega t, and we know the amplitude is 6 centimeters, so we can plug that into this amplitude. And we know that this final x is negative 1.5 centimeters. So we plug in negative 1.5 centimeters to x. So then we divide by 6, and we'll get negative 0.25 equals cosine of omega t. And we know omega is 20.94. And then we find what the inverse cosine of negative 0.25 is. And that equals 1.82. So then 1.82 will equal 20.94 t. So then we just divide by 20.94 to find t. And t will equal 0.087 seconds. So that is problem 64.